so today we're going to look at section 213, and the title is Converses, and we're going to be answering the question, can I reverse it? So on question 23, it says, in a conditional statement, the if portion of the statement is called the hypothesis, and the then portion is called the conclusion. If you reverse the order of the hypothesis and the conclusion, then you have created the converse of the statement. Part A, they want us to write the converse of the conditional statement. If angles are vertical, then they are congruent. Okay, notice that I underlined the first part with my purple pen, and that may be what exploded all over my arm. And the second portion with the blue, and then I switched them. But some of the words I had to move a little bit to make it make sense. Okay? So I took this second part, what we call the conclusion, and I moved it to the conditional part, and I wrote it as, if angles are congruent, then they are vertical. Okay? So you're just going to take the two parts of the statements and swap them. That's called the converse. All right? Part B just wants to know, is the original statement true? And we say yes, because we learned in chapter 1 that vertical angles are congruent, right? Hopefully you weren't asleep all of chapter 1 and you caught that vertical angles are congruent. The second part of the question says, is the converse true? So the converse says, if angles are congruent, then they are vertical. So is the converse true? Well, it can be true, but it's not always true. So we have to say no, because any two angles could be congruent. They aren't necessarily because they're vertical. They could just be drawn separately, not even connected, and they could have the same measurement. Okay? Any questions on question 23? All right, I'm going to move this up a little bit in case you're still writing. Then we're going to jump down to question 24. Is that crooked? All right, question 24 says, every conditional statement has a converse. Consider the arrow diagram for a familiar relationship below. Triangles are congruent. The arrow says all pairs of corresponding sides are congruent. Part A. In mathematics, to say that a statement is true, it must always be true. That is, it must follow from a definition or a theorem. Is this diagram true? So if triangles are congruent, all the pairs of corresponding sides are congruent. Yes, that's true. If two figures are congruent, all their sides are congruent. So we say, yes, it's true. Part B, write the converse of this arrow diagram as an arrow diagram or as a conditional statement. Is this converse true? Justify your answer. Okay, so I wrote it as a conditional statement, and I said, if all pairs of corresponding sides are congruent, then the triangles are congruent. And we say, yes, this is true because of the side congruence. Part C. Now consider another statement below. Move that up. Now consider another statement below. Is this statement true? Triangles are congruent, then all pairs of corresponding angles are congruent. Yes, this is also true. Do you remember yesterday we learned about CPC-TC? Corresponding parts of congruent triangles are congruent. This is one of the parts. All right? Part D. Now they want us to write its converse and say if that converse is true. If it is true, prove it. If it's not always true, give a counterexample. A counterexample is a statement showing at least one situation where a statement is false. Okay? So first we're going to write the converse. The converse is that if all pairs of corresponding angles are congruent, then the triangles are congruent. Okay? So side, side, side from part B was one of our 5 congruents, right? And we know that one's true. But this one would basically give us AAA. Is AAA on our list? No, AAA is not on our list. So we have to say false because it's not guaranteed. Okay? AAA is not a congruent statement. It seems like it should be, but it's not. Okay? Part E. Write the converse of the arrow diagram below. Is this converse true? Justify your answer, and it says, if a polygon is a rectangle, then the area of the polygon is B times H. Okay? So the converse of that, we're going to swap the 2 parts, and we have, if the area of a polygon is B times H, then the polygon is a rectangle. Well, it could be true, but it also could be a parallelogram. So we have to give one example to make it not true, which is false. Okay? False, true, false, yeah. Okay? Any questions on part A, B, C, D, or E? It's a lot of writing. Anybody still writing? Okay. Go ahead and keep writing, guys. I'll give you a few minutes to catch up. Page 7 up at the top, question 25 says, for each statement below, rewrite as a conditional statement or as an arrow diagram and state whether it is true or false. Then write the converse of the statement and tell whether it is true or false. Remember that for a mathematical statement to be true, it must always be true. Okay? So for parts A, B, and C, you're going to write each of these as a conditional statement. If something, then something, and then you're going to say whether it's true or false. Then you need to write the converse and say true or false. Okay, so for A, B, and C, conditional statement, true or false. Converse, true or false. Conditional statement, true or false. Converse, and then true or false. So maybe just write all that on your paper. Then we're going to break into groups of 4, and you're going to do those A, B, and C together. Then when you're done with that, you can open up your homework packet and work on section, what is it?